Hey guys, welcome to day 28 of 100 Days of Code. Today we're going to be building a Pomodoro app completely from scratch using TK-Inter and the knowledge that we gained from yesterday's lessons. Now, you've already heard me talk about the Pomodoro technique, this famous book by Francesco Cirillo. This famous technique that helps people time manage and to get more stuff done. Now, if you didn't hear me talk about it, this is basically a very simple breakdown. Essentially, you figure out the task that you need to do, something hard, something that takes a while, like writing your next book or coding up a project. And then you want to set your timer to 25 minutes and then work on the task for 25 minutes. And then after that, you take a short 5-minute break. And after you've done 4 of these Pomodoros, basically 4 repetitions, then you get to take a 15 to 30 minute break. So this basically really effectively utilizes the way that our brain works to take short breaks often and to work for 25 minutes at a time, which helps us with information retention and also keeping up the motivation. This is the program that we're going to be building using TK-Inter. It's going to be a timer with a tomato on it, and when you click start, it's going to tell you to work for 25 minutes. And then that window can go into the background, and while you're writing your code or doing whatever, when the timer is up, it will pop to the very front of the screen above all of the other windows and tell you to take a break. So the first break is for 5 minutes, and you'll notice here we've already achieved 1 check mark for our first Pomodoro completed. And once you're done with the break, then it's going to go back to work and it's going to continue until you reach the longer break or until you click reset to stop and reset the timer. Effectively, it's going to help you do these Pomodoros where you have 25-minute work, 5-minute break. You do 4 of these 25-minute work sessions and then you get a 20-minute break. So hopefully by creating this program, you're going to increase your productivity and you're going to have your own handy tool to help you achieve more and do more. So this is what we're going to be building. Once you're ready, head over to the next lesson and let's get started. The first thing I want you to do to get started is to head over to the course resources and download the starting files for the Pomodoro project. Once you've got that, then you should be able to unzip this file and get hold of the starting folder. Next, I want you to open up that folder using PyCharm. So in my case, my folder is inside my downloads, and then I'll just click open. And PyCharm should automatically configure the latest version of Python you've got installed. So if you take a look inside this folder, there's 2 files. There is an image of a tomato, which we're going to use in our project. And there's also a main.py with a couple of sections already hashed out for you. And we've also included some constants like some color hex codes or a font name or the number of minutes for working, short breaks and long breaks. So that's already in the starting file. The first thing we're going to do is to set up our UI. So under the section UI setup, we're going to create a new window using TK-Inter, and we're going to get the window to run and give it a background color. Pretty simple. So let's go to the top of our file and import our TK-Inter module. And then if we scroll down to our UI setup section, let's go ahead and create a new window from the TK class. Remember that our TK class is one of the classes from TK-Inter. So you can either tap into the TK-Inter module and then get hold of the TK class like I have done here, or as in our case, if we're going to be using a lot of classes from TK-Inter, then we can simply say from TK-Inter, let's go ahead and import all of the classes. So that way we can straight away refer to this TK class. Now that we've created our window, the next thing we can do is to set the title of the window, which you can of course call it anything you want, but in my case, I'm going to set it to just Pomodoro, which just means tomato in Italian. So now that we've got our Pomodoro, Then we're going to get our window to show up by using window.mainLoop as usual. And now if we run this code, our main, you can see we've got a blank window, a title, and we're ready to go to the next step. The next step is to put an image into our program so that we can have this tomato as the background of our program, and then we can put some text on top, which is going to signify our countdown timer. This is what we're aiming for, but to achieve this and to be able to put images onto the screen which look like this, we're going to have to learn about the tkinter canvas widget. A canvas widget is a little bit like a real life canvas, really. It allows you to layer things one on top of the other. So you could draw something and then you can draw something on top of that. And what it allows us to do in our case is to place an image onto our program and then to place some text straight on top of that. In between our window creation and the window main loop is where we're going to create our canvas. And our canvas is created using the canvas widget, of course. One of the things that we can specify when we create our canvas is a width and a height. And that will be a value in terms of pixels. So we know that we want to display this tomato image inside that canvas. And we can see that this has roughly a width of 200 and a height of 223. So let's create a canvas that's roughly about the same size as the image. So we'll put a width of 200 and a height of 224, just so that we work with some even numbers. Once I've created my canvas, the next thing I want to do is to add my image to it. And we can use a method that the canvas has, which is called create image. And as soon as I type create, you can see there's actually a whole bunch of other methods like create the text in the canvas, create a rectangle, create an oval. And all of these things could be overlapped on each other inside the same canvas. Now, when we create an image, there's a couple of things which are required. The first thing is the X and Y positions of this image in the canvas. Given that we have a width of 200 and a height of 224, I want my image to be bang in the center of the canvas. So I can provide the X value as half of the width and the Y value as half of the height. In addition to the X and Y values, we also have to specify an image. But I can't just simply type the name of my image, which is tomato.png, because that is not the type of data that this argument is expecting. What it wants instead is something called a photo image. And this class comes from tkinter, and it's basically a way to read through a file and to get hold of a particular image at a particular file location. In my case, the file location is in fact tomato.png, and if your image was stored in, say, another subfolder or a different place, then you should provide the relative or absolute file path to get there from where your code is, which is the main.py. But in our case, it's very easy. They're both in the same folder, so we can simply specify our file name like so. The next thing we're going to do is we're going to save this photo image in a variable so we can refer to it later on. I'm going to call this our tomato_img. Feel free to call it anything you want. And that is the data that goes into this image argument. Now we've created our canvas, we've created our photo image, we've told our canvas to create an image at this position, and then we've put the image inside. The final thing we need to do is to pack our canvas or use some other sort of method to specify the layout of how the canvas is going to go on the screen. And now we can hit run and we can see our image on the screen. So now notice how the image is basically taking up the entire space of the window, and in fact the window is resizing itself to fit this image. Wouldn't it be better if this screen was actually a little bit bigger so we don't just look at the image of a tomato? We can do that by getting our window to be configured And the configuration that we want to change is the padding. So I'm going to change the pad X and pad Y. On the x-axis, on the horizontal, I'm actually going to add a whole 100 pixels of padding on both sides. And then on the y-axis, pad Y, I'm going to change that to 50 so that it's got 50 pixels of padding on the top. That's looking pretty good, other than one small defect. You can see that our tomato image is a little bit cut off on the left. And I suspect this is because the actual image is a little bit shifted over to the left. So we can actually adjust this X position to be a little bit more to the right. And that way our tomato can be centered on screen without being cut off on either side. So now that we've tweaked our image and we've displayed it on screen, the next thing to do is to display some text. As you noticed before, in addition to canvas.createImage, there were a whole bunch of other things we could create, including some text. This create text method works very similarly to the create image method. Notice how the first thing that's getting highlighted is the single asterisk args, and then we've got our two asterisks quargs. So remember from the lessons yesterday, these arguments are the unlimited positional arguments, and these arguments are the unlimited keyword arguments. So the keyword arguments here are, for example, the image or the background color or anything else, but these are the X and Y values. So creating the text, we also have to provide a X and Y value. So I'm just going to try the same values as the image to see how that looks. And now we can add some keyword arguments, for example, the text. So I just want it to say 00:00, which looks pretty much like the clock. Now, if we run our code, you can see we've got a little bit of text showing up. Now notice how it's a little bit high up on the tomato, because remember the tomato starts at the top here and ends here. So that is the center of the tomato image, but we can move it down a little bit so that it's actually centered in this red part, the circular part. With a little bit of experimentation, I think this 103:130 actually works quite well, and it's pretty much bang in the center of the tomato. Let's modify this text in some other ways. We can change the fill, which is basically the color of the text, and I'm going to change that to white, that you can see here. And then I'm going to change the font as well. And this is going to expect a tuple. So it's going to be the font name and then the size, and then whether if it's bold or italic or whatever else you want to do. Now in the constants here, I've already got the font name defined, which is going to be Courier that we're going to be using. So we can straight up add our font name, and then we'll add a font size as 35, and we'll say, yeah, make it bold. So there you have it. We've got our tomato, we've got our text showing up as the countdown timer. Now, the final thing I want to do is just change the background color to a slightly nicer looking color. Now, one of my favorite websites is this one called Color Hunt, which shows you a whole bunch of different color palettes that professional designers have created, and it makes it really easy for us to just snap up some of these hex codes and use them straight away in our program. Now, the one that really caught my eye is this one, because it has a bit of the tomato color palette. So I've transferred all of these hex codes to the constants in the starting file. So you can see I've got the pink, the red, the green, and the yellow, and we're going to be using that across our program to give it that consistent color theme and make it look like it's been professionally designed. So what I want to do is I want to change the Windows background color, and I can do that through the keyword argument called BG for background, and I can set it to a hex code. So a hex code starts out with the £, and then it's some numbers and some letters. Now I've already got all of that for you, and all you have to do is just to put down the name of the constant. So this should not be in quotation marks because it's not the word. It's in fact referring to that particular variable and the string that's held inside. So now if we check our screen, you can see the background has been changed to that nice yellow color, sort of rice or hay color, but the tomato, namely the canvas, still has that white background. So let's change the background color of the canvas as well. And again, it's using the BG. So some of these you'll notice are standard attributes that we can change, like the width and the height and the background color, which is standard across all of the widgets. And some other things like file here are some of the more specific keyword arguments. So let's apply this yellow to the background of the canvas. And you can see that the canvas is now yellow as well, but it's still got this little white border, which denotes the edges of our canvas. To get rid of that, I found a specific keyword argument that would actually help. And it took quite a bit of digging around, quite a bit of Stack Overflow searching and Googling in order to find this. It wasn't very straightforward because tkinter is not well documented, unfortunately. But thankfully for you, all you have to do is find your canvas, and on the line where you've created it, go ahead and add this keyword argument. It's called highlight thickness. And be sure that you spell it right because it's really long. And remember, there's two T's because it's highlight and thickness, and there's nothing in between, no underscore, no nothing to separate it. I think the tkinter team could have really done a little bit better here, but hey. If we set the highlight thickness to 0 and we rerun our code, then you should see that it now looks pretty good. And our canvas is now completely the same color as the background of the window. And you can't tell where the window begins and the canvas ends. Now, the only problem is once we've removed that border around the canvas, our tomato is once again shifted a little bit. So we can actually adjust this and we can change this back to 100. And I'm going to change it both for the text and the image. And we can make that tomato image perfectly round once more. With tkinter, I found that you have to do quite a bit of tweaking around, especially with these positions. And you'll spend some time judging it by eye in terms of the size and the width and where to place it. But we have now successfully managed to place an image onto the screen, change the background of the window, keep it consistent, and add a little bit of text onto our tomato. So now we're ready for the next step. In the next lesson, we're going to create the rest of the user interface, and that is mostly going to be up to you. So for all of that and more, I'll see you on the next lesson. In the last lesson, we started setting up our user interface, and we created this canvas, placed our image onto it, and also on top of that, put some text. This is how far we've gotten, and we want to now complete setting up the user interface. So adding in some more components. And we want it to end up looking a bit like this, with a label at the top, a big bit of text, some buttons at the bottom, and also a label that keeps track of how many Pomodoros we've done. So each 25-minute work session gets us a check mark. So you're going to be using a lot of the stuff that you learned in yesterday's lessons in terms of which tkinter widgets to use and how to set them up in order to create this. So it's going to be a challenge for you. But before we get started, there's just a couple of things I want to point out. So one thing to note is that we've got this BG, which stands for background color, and we've used our constants up here to set those background colors. Now you can see that here I've got the label and also the check mark in a green color. And that color comes from our constant right here. So you'll be able to color a piece of text in a label, not by using BG, but by using FG, which stands for foreground. And that you can basically set to equal the green color that we've got. And as long as that's added to the label, then you should be able to see that show up. Now, the other thing I want to show you is if you don't know how to get hold of a check mark, the easiest way is just to go onto Wikipedia and find the particular check mark that you like, and then just copy it and paste it into here as the text. So for example, if we had a label which had a text argument and I copy that check mark and I paste it here, then that check mark is what's going to show up on screen. Now, the final thing I want to mention before I let you get on with the challenge is that we've packed our canvas onto the screen. But as we've got quite a few things that we need to lay out on the screen, it's much easier to do this using the grid. So I want you to change the canvas to using the grid system. And here I've created a more or less sort of breakdown of how that grid might look like. So you probably will end up with 1, 2, 3, 4 rows and 3 columns, and have a think about how you might lay out the labels and the buttons and the check marks relative to those rows and columns. Keeping this page on screen, I want you to pause the video and give this challenge a go. And if you don't know the sizes for things or the fonts, don't worry, just guess them. It doesn't really matter. As long as you've got the rough layout and the correct widgets, then that would be considered a win. Pause the video now and give it a go. All right, so I'm going to get started by creating this top label here. And that I'm going to call the title label, and that's going to be created from the label class. Now, the text in this is just going to read timer for now, and I want to change its color by using the foreground keyword argument, and I'm going to change it to that green color that we've got up here. Now, I want to be able to show that label on screen, so I have to give it some form of layout. And as we mentioned, we're going to use the grid system. So I'm going to change the grid. And if we refer to this image, you can see there's going to be 3 columns. This is going to be in the middle column, and then it's going to be on the first row. So we're going to start from 0. So I'm going to say column equals 1 and row equals 0. Now I have to change this canvas pack because otherwise it's going to give me an error. And in terms of where the canvas is, it's going to be again in the same column as that label, but it's going to be on the next row. So column 1, row 1. And now when I run it, you can see our label shows up and then our canvas shows up, and it's all correctly positioned. Now I want to change this label so that it looks a little bit more like the demo that I showed you, like this. So I have to change the font and the text to make it a lot bigger. As we've seen before, we can simply add the font when we create the label. So we can set that to a tuple, and first I'm going to use my font name that I've got as a constant, which I've used when I created the text. It's just going to be Courier. And then in terms of the size, you can simply just make a guess. It's going to be something pretty large. So I'm going to go with 50. And I'm not going to have it bold or italic or anything. So that's the end of that font. And now when I run it again, you can see it's a lot bigger and it looks a lot more like the example that we had here. But the only difference is that it actually still has a white background. Instead of just changing the foreground, I'm also going to change the background, and I'm going to make it the same yellow color that I have in the background of the window. So now it looks like it's all blended in and it's all a part of the same application. Let's move on to the next row, which is going to be our buttons. So I'm going to have a start button, and I'm also going to have a reset button. And they're both going to be created from the button class. The start button is just going to have the text start, and the reset button is going to have the word reset. The start button's also going to be laid out on our grid, and it's going to be column 0, row 2. And the reset button is going to be column 2, row 2. So now you can see the start and the reset buttons are now on the next row after the canvas, and it's either side of it. Now notice how there's a little bit of a white background around each of the buttons. If that bothers you, then you can actually fix that by doing the same thing that we did with the canvas, which got rid of the border, by changing that highlight thickness to 0. And because that's really prone to typos, I'm actually just going to paste it in. So now you can see that white border has pretty much all but disappeared. Now we're on to our very final thing that we showed, which is the check mark right here. So I'm going to call it check marks because eventually there'll probably be quite a few of them, hopefully, if we do lots of good work. And our label is going to have the text, which is going to have the check mark. Now, if you're on a Mac, you can actually go into Edit and go to Emojis and Symbols and pick a check mark from here. But on Windows, you can simply just use the trick that I showed you. Go ahead and copy and paste it from a piece of text, say like Wikipedia. Once we've got our text, I'm going to change the foreground color of that text again, and I'm going to change it to green. And it's also going to require a background color of yellow, just so that we get rid of the white. And finally, I'm going to add this on using the grid, setting the column to 1 and the row to 3. So this is basically going to be in the last row. So you can see after all of that work, we've finally managed to complete the user interface. And we've now achieved the final look. And all we need to do now is to actually add the timer functionality, which we'll do in the next lesson. Now, if you found any of the TK Inter widgets difficult to use, or you got stuck, or you couldn't figure out certain things about it, then be sure to have a review of yesterday's lessons where we talked about the widgets in more detail. In the last lesson, we completed the user interface for our Pomodoro timer, and we've managed to get all the components that we need onto our graphical user interface. Now, the next step is to actually give it some functionality. I want to be able to create some sort of countdown mechanism that just does something really simple. For example, if it was just able to count down from 5, 4, 3, 2, 1, going down by 1 each time. That would be great. That's what we're going to be working on in this lesson, and we're going to go into the countdown mechanism section to do that. One of the ways that you might think about approaching this is to use our time module, because we've seen before that we can say time.sleep and we can tell it to sleep for a second. So then we could maybe set up a while loop, and while something or other is true, go ahead and sleep for 1 second, and then afterwards just, subtract 1 from some sort of counter. So we could start count at 5, and then each time we subtract by 1, and then each time we just simply update our label here, which we created in the canvas, to whatever value count might be. Now, that sounds great in principle. The only problem is that we're working within a graphical user interface program. The reason why that's relevant is because if we think about a command line program, say, for example, if we were to get our console to do something, print hello, well, it's only going to do something when you actually give it an instruction and you hit enter. It doesn't really need to keep an eye out for what you might do in between. But a graphical user interface is a little bit different. It needs to keep watching the screen to see whether if a user clicks on a button, for example. So it's basically going to refresh and keep listening for events. So every fraction of a second, it's going to keep checking, did something happen? Did something happen? Did something happen? And the moment when it does, then it's got to react. It's got to react to that event. In this case, we tend to call these types of GUI programs event-driven. And the way that it's driven is through our main loop. So when we set up our window and we start off the main loop, it's basically looping through, and every millisecond it's checking to see, did something happen? Did something happen? Did something happen? So that means if we have another loop in our program, it actually won't be able to reach the main loop. And in this case, when you actually try to run it, nothing happens. Our program doesn't even launch. So we have to rethink this, and we have to do it a little bit differently. In order to create interactive and interesting programs, you kind of need something to happen on screen, right? Every so often. You need this timing mechanism. Luckily, TK Inter already thought of this, and we can in fact use one of the built-in methods to every widget. So if we tap into our window widget, we can get hold of a method called after. And after is quite simple. It's a method that takes an amount of time that it should wait, and then after that amount of time, it simply calls a particular function that you tell it to call, passing in any arguments that you want to give it. Here's how it works. We call window.after. We first provide the amount of time to wait in milliseconds. So if we want 1 second, then that's 1000 milliseconds. Next, we pass in a function to call. So let's create a function up here. Let's just call it, say, something. And then we'll pass in the thing like this. And then all we do is we just print that thing. So super simple function, and then we give the name of this function as the function to call after 1000 milliseconds. Now, the final thing in this list of arguments, if I just go ahead and cut that and show you again when it gives me the prompt, the last thing is actually a asterisk args. This, if you remember, allows us to put in an unlimited number of positional arguments. What that means is we can give as many arguments as we want, and those arguments in this case is simply going to be passed to the function that we want to call. So in this case, it's going to be that thing. So if I put hello here, then I run my code, you can see that after 1000 milliseconds, basically 1 second, it calls this function say something, and it passes this hello as the input to that function. As I said, you can have an infinite amount of positional arguments. So let's put in some other arguments, which we'll call A, B, and C, and then we'll print A, print B, and print C. And now, instead of passing in hello, we're going to pass in lots of positional parameters. So we'll say 3, 5, and 8. Now, when I hit run, you'll see it waits for 1 second, and then it passes all 3 of these parameters to say something, and it goes ahead and prints all of those out at once. So this is how the after method works. But what we want it to do, though, is we want it to repeat itself, to essentially loop. One way of getting that behavior is to simply put this method call somewhere inside a function and then call itself. So here's what I mean. Let's create a function called countdown, and this is going to take a input in the form of the number to count down by. And then inside this function, we call window.after. And we say that after 1000 milliseconds, call this function countdown, and then pass in a count number. If that count number started out as 5, then we want to say count minus 1. Now, all we have to do is to call this countdown method. So let's call countdown and pass in the starting count, let's say 5 seconds. So now when I run the code, it's going to call this method, passing in 5 over here, and then it's going to wait for 1 second, and then it's going to call this function countdown, passing in 5 minus 1. So it becomes 4. And then afterwards, it repeats again, becomes 3, 2, 1. So now if we catch that number, which we can print, then we'll be able to see it count down when we run the code. 5, 4, 3, 2, 1. 1 every second. And it basically keeps on going, and it even continues to the negatives. So if we don't want it to go to negative time, then all we have to do is add an if statement. If count is greater than 0, then go ahead and execute this line of code. So now it'll go from 5, 4, 3, 2, 1, 0, and then it will stop. this is the kind of behavior that we would need if we want to update our countdown in our Pomodoro timer. So how can we, instead of printing the count, actually change this text on our canvas? Well, the way that we do that is by assigning this text a variable. So I'm going to call it timer text. And now that we've got timer text being set as the text that was created in the canvas, then we can access it right here. And the way that we change a piece of text, or anything for that matter, in a canvas is slightly different from how we would do for a label. If it was just the title label that we wanted to change, we would say title label.config, and then let's change the text to something new. But to change a canvas element, you actually have to tap into the particular canvas you want to change, and then you call a method called itemConfig. And then in this method, you pass in the particular item that you actually want to configure. So in our case, it's the timer text. And then you pass in the thing about it that you actually want to change in terms of a quag. So this is a keyword argument. We're going to change the text to the current count. Now notice how this is not the string count, because then it would just show that word, but it's actually the live countdown time. At this point in time, if I run the code, I actually get an error, and it tells us that the name canvas is not defined. And that's because I'm calling this method countdown before I actually created the canvas. So if I move that to below this line and I run it again, then you'll see it actually work. And you see it starts out from 5 and it counts down to 0. Now, how can we tie that behavior to the start button so that I can press the start button and then, and only then, does it start counting down from 5, 4, 3, 2, 1? Well, let's go ahead and add another function, and I'm going to add it in the timer mechanism section, and I'm going to call it start timer. Now, this function is super simple. All it's going to do is it's going to be responsible for calling that function countdown, and it's going to count down from 5 seconds. So I'll move that inside the start timer, and now the start timer is going to be the function that needs to be triggered when the start button gets pressed. Do you remember how to tie a function to a button in tkinter? Pause the video and see if you can solve this challenge so that you'll be able to run the code, hit start, and the timer to start counting down. So the keyword argument is command, and all we have to do is to tie it to the start timer function, but without the parentheses. So now when I hit run and I click start, it starts the timer, setting that text from 5, 4, 3, 2, 1. So the main loop is listening, and when the user interacts with the start button, it actually calls the start timer function, which calls the countdown function, and get it to count down from 5 seconds. Now, we don't actually want to count down from 5 seconds. We want to count down in minutes, because we're probably not going to be working for 5 seconds at a time. We're going to be working for 25 minutes or having a 5-minute break. So how can I change this countdown to interpret this instead of as 5 seconds to 5 minutes? Well, let's have a think about that. If we wanted to count down, let's say 1 minute, then that in terms of seconds would be 60 seconds. All we have to do is to take the number of minutes that we want to count down by and multiply it by 60. In this case, if we wanted to count down by 5 minutes instead of 5 seconds, all we have to do is multiply by 60. So then when we call this function countdown, instead of getting 5 seconds to count down, we get 300 seconds to count from. But now if we run our code, you can see it's going to start from 300, it's going to go down all the way down to 0. Now in terms of time, that is 5 minutes, but this is not a very good way to visualize it. Nobody thinks in terms of 288 seconds remaining, right? So we have to format this count so that we can display it in the format of 0000, like the usual kind of time, where, for example, you have 1 minute and 35 seconds remaining, or something like that. So how can we create something like this? If we have the count in terms of seconds, so let's say we had 300, and we wanted to know how many minutes were in that, then all we have to do is take 300 and then divide it by 60, and we would get 5. So that's 5 minutes. But what if the countdown has already been going and instead we had 245 seconds remaining? Well, we can actually get hold of how many minutes and seconds that is equivalent to. And the way we would do that is by taking that number, say 245, dividing it by 60 seconds, and we would get a number. 245 divided by 60 is 4.083 reoccurring. If we rounded that number down to get rid of all of the decimal places, then that would be equal to 4 minutes. And then if we want to get hold of how many seconds there are after we've gotten hold of the 4 minutes, then the way we would do that is to use the modulo. Because remember, the modulo divides a number by another number, so 245 divided by 60, and then it will give us the remainder, how much is left after it's cleanly divided. And in this case, this would actually be the number of seconds remaining after the 4 minutes has been taken away. So let's write this code out. The count minute would be the count divided by 60, but then we have to round it down so that we get rid of all of the remainder. Now, we don't want to round it so that if it was something like 3.6, it becomes 4. We actually just want to get rid of everything after the decimal place. To do that, the easiest way is to import the math module and then use a function called math.floor. And this math.floor, if I hover over it, is going to return the largest whole number that is less than or equal to x. If this was 4.8, then the largest whole number less than 4.8 is 4. So that's basically what this is going to do. And this is going to give us the number of minutes. Now, the next thing we want to do is to know, well, how many seconds is left after we've taken away the minutes. To do this, we're going to do count, and then we're going to use the modulo to divide it by 60. So the modulo is going to give us the remainder number of seconds after we've cleanly divided it by 60. For example, if we had 100 seconds and we divide that by 60, well, that's going to be equal to 1. So we can minus 60 from 100 and we get 40 as the remainder. That is what we will get after doing the modulo. So that's basically the number of seconds that remains. So now that we've got the minute and the second, we can actually change this count to use an F string. And we can format it so that we add the count minute first, and then we add a colon, and then we add our count in seconds. Now look at what happens. We're going to try and count down 5 minutes. So we get hold of the number of seconds, we pass it over to this function. We work out what the count is equivalent to in minutes and seconds, and then afterwards we subtract 1 second each time. So now when I run the code and I hit start, notice how it starts from 5 minutes, goes down to 4 minutes 50, 59, and then it keeps on going like a real timer. That's pretty cool. The only thing left to figure out is how can we get it to not display 5:0? How can we get it to display 5:00 like you would see on a clock? To find out how to do that, we have to learn about Python dynamic typing. We have to understand how that works. And that is what we're going to be talking about in the next lesson. So I'll see you there. in the last lesson, we managed to get our countdown mechanism to work, and we got it to count down from 5 minutes to 0. Now, everything works, but there's just something a little bit niggling, and you'll see it when I hit start. Notice how it says 5:0. Wouldn't it be so much better if it said 5:00? So how would we do that? Well, that 0 comes from this count sec, because it's taking the count in seconds, dividing it by 60, and finding the remainder using the modulo. Now, when there's no remainder, it's just going to be equal to 0. So we could use an if statement and check, well, if the count sec is equal to 0, then instead of making it 0, let's set it to equal a string, which is 00. Now, this actually, believe it or not, works. And you'll see it when I run it and when I hit start. Doesn't that look so much better? But some of you might have realized that there's something a little bit crazy going on here in these 2 lines of code. We're checking to see if this variable holds data that is equal to the integer, the whole number, 0. And then we're setting it to a string. So these are completely 2 different data types. That's an int and that is a string. So how is it that we're able to do this? So let me pull up the Python console. We know that if we took an integer, say 3, and we try to add it to a string, say a 4, this is not going to work and we get a type error because this is type int and this is type string. So you can't actually add these 2 together because there's a mismatch. Now, here's the crazy thing. Let's create a variable a and let's make it hold the integer 3. And at this point, you can see that this a variable has a data type of int. If I decide to change that variable and make it hold a different type of data, let's say the number 4, or let's make it simpler, let's make it hold the piece of text, hello. As soon as that goes through, you can see that a is now of data type string. And the very fact that I'm able to do that, change a variable's data type by changing the content in that variable, this is what's known as dynamic typing. In this sense, Python is a language that's quite unique because on one hand, it is strongly typed in the sense that it holds on to the data type of the variable. So this a is a string and it knows that it's a string. And if you do something that is not meant for a string, say if you tried to raise a to the power of 2, then that is going to be a type error. Types matter, and when you call a function that's expecting a particular type, say if you use the power function, which is expecting an integer, and you pass in something that's obviously not an integer, say our string here, and you try to get it to do something, say raise it to the power of 3, then again we get type error. It knows what type is supposed to go into that function and it makes sure that you comply with that. This is where the language is strongly typed. But the part where the language is dynamically typed is that even though it knows what type a variable is, it knows what type a function expects, you can also dynamically change the data type of any variable like this. That is basically what we're using here. We're using dynamic typing to change the data type of countSec from an integer to a string. And then we use that string to display inside this canvas text. Now, there is, however, still a bit of a bug with this, and you'll see it once it dips below 10 seconds. Notice that as soon as it goes to 9 seconds, instead of saying 09, which is what you would want, or 08, 06, it just lists the number of seconds until it reaches 00. So how can we fix this? The key lies in these 2 lines of code. See if you can do this as a challenge. Pause the video and see if you can make it so that when it's 9 seconds remaining, it says 09 or 08 or 07, and also 00, of course. Pause the video and see if you can complete this challenge. All right, so basically what we want to check for is when the count in seconds is less than 10, because now it's going to be in the single digits, and instead of having just one digit, we want to add 0 in front of it. So the way we can do this is through just an F string. We can use an F string to add the 0 in front and then add the count in seconds afterwards, formatting that into the standard kind of time format. Now that we've fixed that, if we run our app again and it goes down to 10 seconds, you can see it now says 090807, and it's nicely formatted using our F string. And we're able to do this because of the flexibility of the data types in Python, checking it as a number, making sure it's less than 10, and then formatting it as a string and using the F string. Now, this is not a feature that's available in all programming languages. For example, languages like C or Java or Swift, you won't be able to do this. Once you create a variable and you give it a certain type of data, then it must forever hold on to that type of data. But Python allows you to change the data type of a variable just by assigning it to a different type of value. There's a really well-worded Stack Overflow answer that addresses this exact thing I'm talking about the fact that Python is a strongly dynamically typed language. And I recommend that if you want to dig more into this, to have a read of this answer, and I'll link to this in the course resources. Now we're almost there. When we hit start, our countdown works and it starts counting down from however minutes we tell it to. Here's a challenge for you. We know that the Pomodoro technique requires us to work for 25 minutes and then after 25 minutes to take a short break, and then it goes back to 25, and this repeats until we've done 4 sets of 25 minutes, and then we get a long break. So I want you to have a think about how you could create a variable called reps, which is going to be a global variable, and you can access it inside start timer by tapping into this global reps. Now, using the modulo or some other sort of mechanism that you can think of, see if you can figure out how to get our countdown timer to count down a different number of minutes. For example, we would start out with work seconds, which is going to be the work in minutes times 60. And then we have our short break seconds and our long break seconds. Now, how can we call this countdown timer so that if it's the first, third, fifth, seventh rep that we're actually doing our countdown, then we want this countdown to do our 25 minutes in terms of work seconds. But on the other hand, if it is the 8th rep, then we want the countdown to work on our long break seconds. But if it's the 2nd or 4th or 6th rep, then it should count down to our short break seconds. Essentially, what we're trying to achieve is for our countdown timer to do 25 minutes, then 5 minutes, then 25, 5, and until we've done 4 sets of 25, then do we get a 20-minute break. So have a think about what you've done before using the modulo and see if you can figure out how to get this to work in your code. Pause the video and see if you can complete this challenge. All right, so what we want to do is first, when we start the timer, to increase the reps. So we're going to increase it by 1. So now it starts out at the first rep or the first repetition. Now on this first repetition, it's going to need to run this particular line of code. And then when it gets to the second repetition, it needs to run this line of code. And finally, when it gets to the 8th repetition, then it needs to run this line of code. So we can actually use a if statement to check for all of these things. So here we can check to see if the reps modulo by 8 is equal to 0. If the number of reps divided by 0 has no remainder, then that means it's actually the time for a long break. Now, elif though, or else if the reps is actually even, so if modulo 2 is equal to 0, then in this case, it should be time for a short break. And finally, if it's none of those conditions and we have an else statement, then it's just a normal work time. Now, we might think that's all that's required, but as usual, we have to test it to be sure. So let's go ahead and change our work minute down to 1 minute so that we can run it and have a reasonable chance of seeing when it actually finally reaches 0. Once our timer counter goes down to 0, we would expect it to go to a 5-minute break, but it doesn't. It actually just stops. And this is why we need to test our code and test our programs as frequently as we write code so that we can catch these bugs in terms of our logic. So what's happening here? Well, basically, it's counting down to the number of seconds that we told it to count down to. And then once it's done that, well, that's kind of the end. There's no other way of triggering start timer unless we press the button. So what we actually need to do is to add a else statement here and catch when the count goes to 0, because it's in that moment that we want to actually call start timer once again. And this time it's going to increase the reps and figure out which countdown we actually need to go to. So if we run this code again and I fast forward through the timer, you can see that now once it hits 0, it's going to go straight to our 5-minute break and it continues the timer. Now, as the user though, it's quite hard to tell whether if I'm in a work section or if I'm in a break section and what's actually going on. So we should improve the user experience by changing this title from saying timer to whatever it is that the user should be doing. So if they are in this long break countdown, then it should say break. If they're in a short break section, it should say break. And if they're in the work section, then it should say work. So the label that we need to change is this title label. And I also want to change the color, the foreground color, so that when it's work, it's green. When it's a short break, it's pink. And when it's a long break, it's red. So of course, I'm referring to these constants over here. See if you can complete this as a challenge and get that label to change to display to the user what they should be doing each time. Pause the video and complete this challenge. Okay, so when they're on a long break, we're going to get our title label to configure it and change the text to say break. And we're also going to configure the foreground color at the same time, and we're going to make this the red color. Now for the next one, which is the short break, it's also going to read break, but in this case, the foreground color is going to be pink. And finally, when they should be working, the foreground color is going to be green and the label is going to read work. So now when it's during a work session, it will say work. And when it switches to the break time, then it's going to say break. And because this is pink, this is of course the short break. We can also see that we've got 5 minutes and counting. And when it gets the long break, after 4 sessions of work, then the text would be red and the countdown would show 20 minutes. We're pretty much almost there. There's just a couple of loose ends to tie off. One is to change this part so that we actually get a check mark for every successful work session we complete, and also to make sure that our reset button works so that when we click on it, the timer stops and goes back to 0. So for all of that and more, I'll see you on the next lesson. Now we're at the final stretch. Our Pomodoro program is almost complete. We've got this beautiful user interface, we've got beautiful colors from our Color Hunt color palette, and we've got pretty much everything functioning other than just some loose ends. So the first thing I want to fix is this section with the check marks. So we've created our check marks, which is a label that currently just contains a single check mark. Now I'm actually going to cut this check mark and delete the text here because I want that label to start out as empty. Now the only time when I want that label to get an extra check mark is when the user has completed a work countdown. So once they've completed their 25-minute session, then they should get that check mark. To do that, I'm going to write the code inside this else statement, because every single time a countdown completes, it's going to go into this else statement because the count goes down to 0. Now currently we're just getting the timer to restart itself and go to the next session. But what we want to do here is we want to check to see how many reps we have. And for every 2 reps, then that means we've completed 1 work session, because it's work, then rest, then work, then rest. So for every 2 reps, we've completed 1 25-minute work session. So here's a challenge for you. So have a think about how you can use our variable reps to check so that for every 2 reps we've completed, we add a check mark to this check mark label. Pause the video and see if you can complete this challenge, then test it out and see if you manage to get it right. All right, so we know that the reps is equal to the number of sessions we've had. So for example, if we've done 4 reps, then that means we've had 2 work sessions and 2 breaks. That means we can basically divide reps by 2 to get the total number of work sessions we've done. What I can do is I can create a temporary variable called mark, which is just going to be an empty string to start off. And then I can create a for loop to loop through a range. And the range is going to go from 0 up to our reps divided by 2. Now, this is giving us a warning at the moment because reps divided by 2 or anything divided by anything becomes a floating type number. In our case, what we want to do is we want to use that math.floor again so that we can floor this reps divided by 2 to a whole number, and that way we get the correct number of work sessions. If you want to make this a little bit more clear, the next time you read your code, you can actually create a work sessions, and we can move this part of our code over to here. So the total number of work sessions is equal to the reps divided by 2 and then rounded down to the nearest integer. And then we can use that number of work sessions to create our range. When we've created our range, we know that this loop is going to run for that many times. So we can add to our mark. For every single time the loop runs, I'm going to paste in a check mark. You should have that check mark that you had from previously, and you can paste it into here. Now, once we've completed that loop, then all we need to do is to update our check marks label by calling config and then changing the text to equal our mark. Now, in this case, it probably makes sense for that to actually be plural. So I'm going to use my refactor rename to just add an S to everywhere I'm using this. Now let's test it out. When I hit start, it should start counting down, and once that work session completes, then you'll see the timer go to 0 and our first check mark show up. And for every work session we complete, we get an extra check mark, just to nudge us towards working a little bit harder. The final thing that I want to address is our reset mechanism. So we have this lovely reset button, but it's not really doing anything at the moment. What I'm going to do is create a new function here, which I'll call reset timer. And what this reset timer is going to do is basically it's going to reset all the check marks, reset the text inside the timer, stop the timer, and change this title back to the text that it originally had, which is just the word timer. Now, the hardest part about this is actually stopping the timer, because what we have to do is we actually need to tap into that window.after again. But instead of calling after, we actually want to call after cancel. This way, we can actually cancel the timer that we had set up previously. This is the thing that we want to cancel. And if we want to cancel it, we have to give it a name and we have to put it inside a variable. So I'm going to call this my timer. But because this is going to be a local variable, because it's created inside this particular function, I actually have to bring it out. I have to make it a global variable. So I have to create it up here. But what value do I give it? Well, initially, it's actually not going to have any value at all. So it's going to start out as none. And then later on, I'm going to tap into that global timer in order to get it to hold on to this. Now then, once I want to reset my timer and cancel it, well then I can actually tap into this global timer and stop the timer. So now to actually activate this function reset timer, we have to add it as a command to our reset button. So where we create our button, I'm going to add it as a command. And remember, we have to get rid of the parentheses. So now if I run my program and I start my timer, you can see that as soon as I click this reset button, it stops my timer and it doesn't continue. So now all we have to do is to add all of the other things that we have to reset. For example, the text in here, we want that to read 00. So that was the timer text from our canvas. And then the other thing we want to do is the title label. We want to set that to just read timer. And finally, we want to reset our check marks. So that once you hit the reset button, it resets this title label, the timer text here, stops the timer, and gets rid of all the check marks, like this. Pause the video and give that a go. All right, so the first thing we want to change is our timer text. And because the timer text is created in the canvas, we have a slightly different way of changing that. So we call canvas.itemConfig and then pass in the thing that we want to change, which is the timer text, and then the attribute that we want to change, which is its text. And then we change that to just say 0:0. Go back to the beginning. Now the title label is a lot easier to change. We can say titlelabel.config and then we can configure its text to basically just read timer. Finally, we're going to reset our check marks. So we tap into our check marks label, again using config to change the text back to empty. That's all there is to it. Now, if we reset our work minute to 25, short break 5, long break 20, or whatever it is that you want it to be, then once we hit run, we will end up with our final Pomodoro timer. And it will be now ready for you to start practicing doing Pomodoros and improving your work and your productivity. So I hope you enjoyed making this fully functional tkinter application with me, and that I hope you will modify this, customize it, make it truly your own, and be able to show off to us what it is that you have done. Because this really is a useful application that you can use, or you can get your friends and your family to start using and show off your hard work.